4-7, the quadratic formula. So in this section, our objective is to solve quadratic equations using the quadratic formula, and to also determine the number of solutions by using the discriminant. Okay? And our essential understanding is that we can solve a quadratic equation, ax squared plus bx plus c equals 0, in more than one way. Okay? And we've done more than one way. We have solving with factoring, and solving by graphing, solving by completing the square. And in general, we can find a formula that gives you the values of x in terms of a, b, and c, which means that we can solve this formula for x. So let's see what this formula actually looks like. So we have our standard form, ax squared plus bx plus c. Okay, we can solve this to get the quadratic formula. Okay, so first thing I'm going to do is I'm going to solve this by completing the square, which means I'm going to subtract c from both sides. So I have ax squared plus bx is going to be equal to negative c. Okay. Next, in order to complete the square, I can't have that a there. I have to have x squared by itself. So I'm going to divide it out, which leaves me with x squared plus b over ax is going to equal to negative c over a. Next, I'm going to actually complete the square. In order to do that, I need to look at the middle term, and I need to divide it by 2 and square it. So x squared plus b over ax, and then I'm going to take that middle term, I'm going to divide it by 2 and square it. Okay, and now I've added an extra term to the left-hand side, so I'm going to do the same thing. I'm going to add it to the right-hand side as well. I'm going to write it first because I want to. Okay. Next, let's factor the left-hand side. This factors into x plus b over 2a squared. Okay. Now, let's clean up this right-hand side. Okay. Let's simplify this term by squaring everything. That turns into b squared over 4a squared minus c over a. I'm going to combine these two fractions. In order to do that, I need a common denominator. That's 4a squared. B squared is fine, but the c is missing a 4 and an a. Because it already has one a, I need two a's. I need a squared. So it's going to be minus 4a times c. Okay, and then let's bring down my b over 2a squared. Okay. Now, I'm going to take the square root of both sides, which leaves me with x plus b over 2a. That's going to equal plus or minus, because we took the square root of both sides of an equation, b squared minus 4ac over a square root of 4a squared. And I just separated this into two different square roots, which I'm allowed to do. And the denominator, if you can see, is actually a perfect square. So x plus b over 2a is going to equal plus or minus b squared minus 4ac over 2a. Square root of 4 is 2. Square root of a squared is a. And then finally, to get x by itself, I'm going to subtract b over 2a from both sides, and I'm going to be left with a very special equation. X is equal to negative b plus or minus radical b squared minus 4ac all over 2a. Okay. This equation right here that we have not pulled from nowhere, that we have taken by completing the square of a quadratic equation in standard form and simplifying it, is called the quadratic formula. So, as long as we have a quadratic equation that is of the form ax squared plus bx plus c, and is equal to 0. That's important. Always must be equal to 0. If we want to solve it and we can't factor it, we don't have a way to graph it, we don't want to complete the square, we can use the quadratic formula, which is x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. Let's try it. Okay? Don't forget my quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so there we go. Now, here's my problem. I have 2x squared minus x. It has to be equal to 0, so bring the 4 to this side. Subtract 4 from both sides. Now, I could try to factor this. Factors of 2 times the factors of 4, that subtracts to 1. There aren't any. I could think about completing the square, but if I do that, I have to get rid of this 2, which means I have to divide it through everything. And in the middle term, that's going to give me a fraction, which might make completing the square a little more difficult. I don't have access to a graphing utility, so I can't graph it. So my only choice is to use the quadratic formula, which is what this question wants us to do anyway. So in order to use the quadratic formula, I need my results for A, B, and C. Well, I can just look at the equation and see that A is 2, B is negative 1, and C is negative 4. Now all I have to do is plug those numbers into the quadratic formula. So we have x is equal to negative 1, so that turns positive, plus or minus the square root of 1 squared is 1, minus 4 times 2 times negative 4, all over 2 times 2. Okay, so this simplifies into 1 plus or minus the square root of 33, 1 minus 1 plus 32, right? Because a negative and a negative cancel each other out. 1 plus 32 over 4. And those are my two answers. 1 plus the square root of 33 over 4, and 1 minus the square root of 33 over 4. It's okay that we got answers that didn't work out perfectly. These are irrational answers, but they're still just numbers. Numbers where this quadratic crosses the x-axis. 2 places. 1 plus radical 33 over 4 and 1 minus radical 33 over 4. Okay. With this problem, hopefully you could recognize that this happens to be a perfect square trinomial. It is in fact x plus 3 squared. Setting that equal to 0 would give me x is equal to negative 3. But what happens if you didn't see that and you didn't know exactly how to factor it? You could still use the quadratic formula. So we would have that A is equal to 1, B is equal to 6, and C is equal to 9. So x was going to be equal to negative b plus or minus the square root of b squared, which is 36, minus 4 times 1 times 9. Well, 4 times 1 times 9 is actually 36 over 2 times 1, which is 2. So now I have x is equal to negative 6 plus or minus the square root of 0 over 2. The square root of 0 is just 0, so that cancels out. So we have negative 6 over 2 is equal to negative 3. So if you didn't see how to factor the original quadratic, that this was a perfect square, or it might not even be a perfect square, it can be anything that factors. Okay? If you don't see it, the quadratic equation will still work. If your radical works out perfectly, then it was a problem that you could have factored and maybe saved yourself a little bit of time. But if you don't see it, the quadratic equation will always work. Let's look at a word problem. Okay? So with this particular problem, we have that Your school jazz band is selling CDs as a fundraiser. The total profit P depends on the amount X that your band charges for each CD. The equation P is equal to negative X squared plus 48X minus 300 models the profit of the fundraiser. What is the least amount in dollars that you can charge for a CD and make a profit of $200? Well, let's find out. So if we know that profit is going to be $200, and that's going to equal my profit formula, if I want to solve this, because it has an x squared in it, I know it's a quadratic, and if I want to solve it, I have to set it equal to 0, which means that I have to subtract 200 from both sides, which gives me x squared plus 48x minus 500 is equal to 0. Just flip it around. I could try to find the factors of 500 that subtract to 48, but there are not any. So I'm going to plug it into the quadratic formula. A is going to be 1, B is going to be 48, and C is going to be negative 500. Okay? So plugging this into the quadratic formula gives me X is going to be equal to negative 48 plus or minus the square root of 48 squared minus 4 times 1 times negative 500 all over 2. 2 times 1. Okay. Plugging this into a calculator gives me X is going to be equal to negative 48 plus or minus the square root of 304 over 2, which gives me, way back, little mistake. Right? See that? Negative X, negative 1, which makes this negative 2, which makes this negative 2. So not so bad. Okay? Oh, also here, that makes this a negative. Okay? I still know that's right. So it's fine. It works out. Okay? Anyway, so now solving this gives me 2 answers. It gives me 1529 and 3271. 72. Okay? So we have 2 answers. We have the 2 places where this quadratic crosses the x-axis. The question asks for the least amount in dollars you can charge. So my answer is the least amount. Okay? So careful with your signs. Okay? Like me, try not to make a mistake. But just plug the numbers into the quadratic formula and just work them all out. Okay? Next, we have a couple different situations here. A quadratic equation, if you think about it, if we think about what it looks like, okay, we'll get to the picture in a minute, but it can have 2 solutions, like x squared is equal to 4. When I take the square root of both of those, I get x is equal to plus or minus 2. That's 2 solutions. 1 solution, when x squared is equal to 0, take the square root of both sides. You can't have plus or minus 0. It's just 0. Or no solutions, like here, when x squared is equal to negative 4. When I take the square root of that, that does not give me any real solutions. We'll see how we can solve this in the next lesson, but for now, we're just going to say that it has no real solutions. In the quadratic formula, the value underneath the radical, b squared minus 4ac, tells me how many real number solutions exist. So in problem 1, before, there are 2 solutions, and in B, there's 1 real solution. So from back here, which I cleared, there was 1 solution down here, and there was 2 solutions up here. Okay? So that term, b squared minus 4ac, is called the discriminant. Okay? And the discriminant of a quadratic equation in the form of ax squared plus bx plus c is equal to 0 is the value underneath the radical, the value of b squared minus 4ac. this piece right here. If the discriminant is greater than 0, there are 2 real solutions, which should make sense because that means that the graph crosses the x-axis 2 times. It doesn't say which way it goes. This graph represents a positive A. This graph represents a negative A. Okay? So we know that from earlier in the chapter. But from right now, all we're talking about is how many times the graph crosses the x-axis. If the discriminant is positive, it's twice. If the discriminant is 0, it's once, which means the point on the x-axis is the vertex. And if the discriminant is negative, there are no real solutions, which means the graph never crosses the x-axis. It is above the x-axis or below the x-axis, never crossing. Okay? So the value of my discriminant can tell me how many times the equation crosses the x-axis. 2 times, 2 solutions, 1 solution, or no solutions. So if you ever have a question that says, what is the number of, this is important, real solutions, okay, real solutions. Every quadratic, and we'll see that in chapter 5, that every equation from the fundamental theorem of algebra has a certain number of answers, a certain number of roots. Every quadratic has 2 roots. Not all of them are going to be real. So we'll see this case in the next lesson. This case actually does still have 2 answers, but because it's 1 solution, that answer happens twice. And we'll talk about that more in chapter 5 as well. Okay. So, but for now, what is the number of real solutions? Well, if I want to know, use the discriminant. It's set equal to 0, so I'm pretty good. So b squared, negative 3 squared is 9, minus 4 times negative 2 times 5, which is going to be 9. 9 minus 10, 9 minus 40, no, sorry, 9 plus 40, negative times a negative gives me a positive, which is going to be 49. So my discriminant is positive, which means that this quadratic has 2 real solutions. It's going to open down. I could figure out the vertex if I wanted to. I see my y-intercept is 5. I could get all sorts of information from this quadratic, okay? Going back to all the other lessons in this chapter. But for now, all we wanted to know was how many solutions it has, and it has 2 real solutions. This is useful if we want to solve a problem that looks like this. Okay, so projectile motion. You hit a golf ball into the air from a height of 1 inch above the ground with an initial velocity of 85 feet per second. The function, h, is equal to negative 16t squared plus 85t plus 112, models the height in feet of the ball in time in seconds. Will the ball reach 115 feet? Well, the only way to tell is plug in the height, negative 16t squared plus 85t plus 112. So we could set this equal to 0. And now we have negative 16t squared plus 85t minus 114 and 11/12, okay, or 0.91 if that makes you feel better. Okay. If I want to know if this is going to reach a height of 115 feet, if I had 2 solutions to this, my golf ball would, yes. If this is 115 feet, if it has 2 solutions, the answer is yes, and it goes even higher. If this has 1 solution, that means that's the highest it ever goes. And if it has no solutions, that means that the golf ball just never got there. We could also, if we wanted to solve this a different way, we could take a look at my original equation and try to find the vertex and see if the vertex was higher than 115 feet, but this is a little bit easier. Okay? So all we need to do now is do b squared minus 4ac and figure out how many solutions this equation has. So we do 85 squared minus 4 times negative 16 times negative 114.91. When I work all this out, I get that we have 7225 minus about about 6-ish, 2/3. Okay. And you can see that the discriminant is going to be negative, right? This number is bigger. So because the discriminant is negative, this golf ball never reaches a height of 115 feet. If we were to plug it in to the vertex formula, right? If we went x is equal to negative b over 2a, and the y coordinate of the vertex is equal to f of negative b over 2a, I can find exactly how high this golf ball went. But for now, all we need to know is that it does not reach a height of 115 feet. Okay? And that is 4-7, the quadratic formula.